Hello everyone. Today I am here to show you one of the important aspect of PowerFactory is how we can use the defined dynamic models in a standard file. Let's say you get a file of Nordic 32, or you get a PowerFactory file from your employer, or are you working in a project and you have a base case file. So how you can use those, and it might be that there are so many dynamic models in those files, and if you want to learn those dynamic models, how you can use it in your personal files. Let's say you want to use dynamic models already established in Power Factory. Like I can show you here, like if I go to file, like not file, data manager, and this is very important to understand this Power Factory. Everything is in the data manager. Everything, whatever you do, it's saved in data manager, and and we have to understand it very practically, because when you work on the different projects, and also you want to access the DigSILENT library inbuilt models, and you want to make a changes in that, you want to improvise that. So for that you have to understand how this whole ecosystem work. So we can see, like, as I just opened a new file here, which is empty file. So here I can go Nordic, like, file here, and then, like, not here, like data manager. And the moment I open data manager here, you can see this is my name, like Yakum. So this is my username and all the files which I used, all the project files. So I have this project file called 14.1. When I browse this, so these are library, network models, study cases, and settings. And these are the all the project files which I created during my study or during recent times. So, and right now I created a new project file which is Nordic 32 dynamic models. So you can see here on the top my new file name. I created this Nordic 32 dynamic mm, models. So when I go here, I have a library, and everything you created is in library. Like you created your own models or you imported models from somewhere, it should be saved. So we can go step by step. So this is my current project folder, and how you get this information, it's in the bold characters. And I click on library. The moment I click on library, there are the 1, 2, 3, 4, 5, 6 folders. If I click here also, you can see on the right hand side it came. So we have 6 folders: dynamic models, equipment type library, operational library, reports, scripts, and templates. And these folders have a very significant role when we work on a larger projects. And right now everything is empty. Like I can, so you can see it's empty. This is also empty here. This is in operation library. These are the folders. These are the folders, not file. Always, because in DigiSilent or in Power Factory, everything works like folder, like they segregate everything in a folder, or we can say, can come back how these things were. So these are the folders where everything saved and how the network model access different folders. So when I click on operational library here, you can see these are the file, and when I click on, it's all empty. But these are the by default folders created by default. And when I clicked on network model, so we have diagrams, network data, operational scenarios, variation, and in the study cases, we have state right now, we don't have any study cases and settings. So these are the four different, I can say settings, or I can say options you can find in every project. So right now I have Nordic 32 dynamic model project, and in those projects, these are the different options. And now I want to open Nordic 32 actual model. I already saved this file. I think if anybody working with PowerFactory, so when you saved any model or when you open any model, any file, it will open automatically. So I already have Nordic system system file here. You can see. So I want to open this project called Nordic test system, and you can download the Nordic test system PowerFactory file from internet. It is a benchmark model for doing different studies, different simulation studies. So I go click, I go file, and I have to activate project. And when you like to activate, it is the data manager. And I want to open my Nordic test system file. I did this, okay, and no. So here, file, let's let me. So here are the Nordic 32 benchmark model. So this is the north, the central, and the south. This is the Thevenin equivalent of all Nordic 32, like Nordic system, Thevenin equivalent into 32 different buses. So let's say I don't want to tell about uh, how Nordic 32, what are the components all. The focus of this video is to understand how we can use the dynamic model saved in a file and we can import to our project. So if I write here, I can see that there is a plant model. When I do plant model, there is a generator, a governor, AVR, and hydro turbine. So these are the dynamic models. I can we can see that like when I say diagram. So here are it is the diagram. So if you want to understand how this dynamic, how to create the dynamic model from the scratch, we have another video, but here we want to show how we can use the dynamic models from a benchmark file to our file. So here we have a frame called generator, and like this is the frame edge, and these are the slots like generator, AVR. I mean, to understand this, we can again go. You can see like in a dynamic model, we have these slots, generator, governor, AVR, and hydro turbine, and how these things are connected, we call it frame. We have another video of how to define a frame from the scratch. I think if you have any confusion about this, you can go to that video. We can also uh, put in the link description so you can know how to create the frame from the scratch, how to define the slots, and what slots are, what elements are. These are the basics. uh, if you are going into any way further into dynamic models and all. So okay, but here's the catch. We are not we are not trying to create our own model. We are trying to import the model from a benchmark project. So here we can see generator, AVR, governor, hydro, and every slot has its own dynamic model. How we can see that? If I can click this, and or we can also click here, diagram, and then this is a dynamic model of the AVR. If and we are not going here to draw from the scratch, we are using this. So now my objective, how I can use in our file. So this is the most important part. So now we know, and we can also check the hydro turbine, and we can do diagram. So these are the dynamic model, or we can say control diagram, and these are the inputs and outputs and some macros. And if I so here you can see like this, yeah, this is a diagram is read only because this is a green file. I mean, I created my own terms to understand how the Power Factory works. So I say it's a green file because it's cannot you cannot change it. But when I go to again here and I go hydro turbine, and from here I go to the type, and then I go this I would say a white file. I mean it just, and here you can edit, and if can I can just put this my here. So you can see here these are the here in the drawing tools it open like global macros, and these are the like macros are the block diagrams. So these are the like like in MATLAB, as you have the different blocks, like you have a PI controller, you have an integrator, you have a differentiator, multiplier. So in PowerFactory, they call it macros, and these are the different macros DigiSilent gave you to use it. I mean, you can create your own macros also, but these are the macros here. And here, and there is another folder called project macros, and these are the macros used in this file. And I took, or not I, whoever created this dynamic model used this macros from the DigiSilent library. So now we know that these are the files, and which the dynamic model I want to use in my local in my local project or any project which I want to create. So for that we have to, and now we have to know like where all this file saves here. Always everything in data manager. Right now I'm in the Nordic test system project. I open it, and I think this is the PFD file, like Power Factory file created by uh, Power Factory company. And you see like it's a German word. So Beschrungsfalle, it's called uh, different study cases, Betriebs, like operational cases, and Bibliothek, it's a library. So when I open the library, and this is like benutzt definierte model, like what model I'm using in it. So when I open it, And whenever you want to see what's there, when I click here, everything comes here. So you see there is a DSL file, there is a block definition file, and here you see there is a frame H and frame T and composite frame. So here, like when you work on DigiSilent, it's very important to understand those symbols. Those symbols are so important to know. So right now, these, because Perfectory is working on an object-oriented programming concept. Like these are the objects which we are using in the network, right? So, so let's say I have this. See, so they are the three things. The one is the com composite frame. If I can I zoom it? No. So you see how I just see this small red diagram over there, and I can know that if some blocks are connected in this is a composite frame. And this, like, see, AVR written here, and this DSL here. So all the text like AVAR, DSL, DSL, V, and hydro turbine has like DSL. So all the so there is a composite frame and there is a block definition. So this is the DSL file, or we can say dynamic simulation language file. Mean is a frame. Right now we see frame edge, and frame edge is telling us how those different slots are connected. And inside every slot, there is a DSL model, or we can say DSL macros. Like there are so many macros connected like this. So this is a DSL model in inside the hydro turbine slot, and also in AVAR, automatic voltage regulator, and how these different DSL models are connected, we call it frame. We open again. So now you see this is a block definition, or we can say, these are the composite frame, and these AVAR and governor and all are the uh, DSL model, or we can say like block definition, how we are defined blocks. And you see these symbol, these are the macros from the DigiSilent library. Don't confuse with this, but you have to just consider three things. The one is the composite frame and DSL model, and these are the macros. So these are the files saved here. And there's a tab control folder also, and there is a one frame and one DSL model. So these are in this folder. I can minimize this folder. It's called Binut's definitive model, like the used model, and we want to use these files in our project. And I can minimize this, and now I go to Nets model. So Nets model, or we can say, is like network model. And when I go to Nets data, so this is the Nordic 30. This is the Nordic, and in network model, everything you used in your network model saved here. So you can see these are the lines. And what is this? We can open this. So these are like the bus bars. So this round symbol representing the bus bars. And these are the lines. And in Nordic 32, they saved everything in a folder, like, because there are so many generators. So they could have saved here, but they wanted to save separately. So you can see these are the frames of every generator they use, and this we have to understand. Like, and you can see there's a frame T and frame H. So in Nordic 32, they use the two types of generator. The one is the H is for hydro, and the T is for, I think it's for thermal or gas, something like this. And you see that there is a frame T and frame H. So, and here is the catch. When I go to the network defined model, I can see here that there are the two files. One is the composite model frame, frame H and frame T. And you can see these are the red files. I mean, when I say red files, it's like you can see the symbol. And here you, you see they are the green files. So that's how we got to know that first we have to define the class. So I created a composite frame which is of frame H, and these are the object of frame H. And then whenever I have to use this frame H, because we have so many generators, here we say we have like G19, G220, there's approximately 20 generators. So, and I can choose my generator like maybe hydro or thermal, and then I have to create a file, an object of each gen generator, and then I have to use these object. I have to use the object of this this, or I can say I have to use the instance of this object. So this, you see there's a frame H, this H, this H. These both are the instance of this frame H object. This we have to, and when I use these models in my file, like in my small project file, I can show you how we can create instances of the object. But for now, we have to understand how, what is the meaning of this green, and these are red files. So green file are the instances of the frame H object, or we can say that this green object, it's at network because it is using in the network, and this red is in library. We can also check this kind of thing in the DIgSILENT library. Imagine you want to use any dynamic model here. You can see in DIgSILENT library, there are so many folders which DIgSILENT provide you to use it. And then when I write on dynamic models, they are DSM macros and model. They are the different kind of things. I just want to show you when I synchronous generator like DIgSILENT, like governor. See, these are the DSL model files which is in the red. So red means it's saved in library, either DIgSILENT library or your project library. And whenever you have to use those red files in your network, you have to create an instance of this object. I will show you how we can create the instance and we can connect to the library objects. So we can say the green files are the network object, and the red are the library objects, and how we can connect this. are is the most important thing. So here you can see here there is a file and there is a plus. It's called new object. So when I say new object, and here there are different objects. I say like composite frame. You see the composite frame green file come, and then you can connect to this green file to the red file. I will show you. So now we have this clear that what is the red file, what is the green file, and we can also check here also, like when I go to tab control, these are the composite model of the transformers because they use the tab control. We can go it into later, but now I want to show you something also. So I go here and just want to, we can also check from here, like when I go to Nordic, these are the composite frames. We we already know, we can see the content. So these are the frames. Okay, so now we see that how we can use the dynamic models, and if any individual who is beginner in the Power Factory, I would recommend not to follow this because it's become a bit into dynamic models and all. And you can see here it seems like so many operation scenarios, so many network variations and all. So please don't discouraged. Don't feel discouraged if you feel it's advanced. It's very easy. If you go step by step, you will find everything. So now I have created an empty file. So I already created an empty file. I just unfreeze graphical object. I just create a simple uh, one like single machine system. So I take bus bar, bus bar, and I think two bus bar is enough. So first I will my generator because I just have to show you how we can use the different models in our system, in our project. Graphical object, flip at node. Now it's come. I use the transformer, sim- simple transformer, and I just use a load. I mean, we don't have to use a load. I mean, just we can also use a single machine infinite bus, but it's fine. We can use a load and then we can, okay. So now I can define, let's say at 10 kV, I'm generating power and let's say uh, 10 kV and then 110 and to 110, or I can say 70 kV. It's fine, doesn't matter. We are not using any practical system here, just a very simple. And then I can define my transformer. 1 MVA is fine, HV side is 70, LV side is 10. Okay, okay, I selected just flip connection. Okay, and general load, we don't care. Maybe we can check it later. We have to, I mean, here I can also emphasis on one thing. Their select type. So let's say if I say select type, so you see these are the red symbols file. It means it's a library file. It's saved, and always just check here. See, DigSILENT library equipment types and synchronous machine. Like if you just focus on path, no, you will know that these options are coming from where. So you can see, as I told you, everything is in the data manager in DigiSilent library. They are the different folders. DigiSilent provide different models like inbuilt models. So either you can select from here. I wanted to create my own for project type. I say it's 100 MVA and I already select the bus. Let's keep it simple. Okay. And you see there is no plant model right now. I say okay. Perfect. I just see whether, okay, now everything runs, but there's no load and all. No problem. Okay. Now the main thing started. And I mean, if you are not comfortable to work from the data manager, you have to learn because there is no other option. This is the only user interface of DigiSilent you got. So you have to be like you, if you practice a bit, you will be you will get familiar to it. And it's very important to be familiar with DigiSilent, this data manager, because this is the core, this is the central, this CPU. So I know that I have this Nordic. So currently I'm in my project, this Nordic 32 dynamic models. And I know that I already you checked in a Nordic test system file. They in bibliothèque, they have so many models like library models, red files models. So what I do, I just control A and I see control C. And I go to my folder, which is Nordic 32 system and library dynamic models. You see right now the dynamic models folder in my current project is empty. I just copy it, all the files came, okay. And these are the library files. These are the not network files. You cannot use it directly. I cross it. And now when I go to Nordic 32 dynamic models, you can see these files, dynamic models. You see, I copy all the files which were in the Nordic test system into my project. But how I can use it, this is the most important point. And here in this video, I'm explaining how we can use the dynamic models from Nordic 32 benchmark file. In the next video, I can also show you how we can use the dynamic models from the DigiSilent library. Both are like the both have the same process, but how we can do this, it's a bit different. But the core idea is same. So right now I have no dynamic model. So I go to my always data manager, Nordic system model, and in my network model, network data and grid, everything. So see, the, these are the green files. So green files means network file. So these are the network objects. So these two represent the bus bar. One is the load. This is a synchronous machine, and this is a transformer. I'm using currently these network objects, which are coming from a library object, or we can say these are the instances of the library object. So now first we have to now first we have to define a compose model or the composite block. So we can tell to the generator how our different dynamic models like turbine, AVR, and other like hydraulic hydraulic turbine and other dynamic models used or connected. So here you can see object. I selected composite model. Okay. The moment I say composite model, it's a composite model came. I will write as composite model 1. I can write whatever I want. I want to write, okay, let's say composite frame H. I say, okay. So now you see there is a empty object, network object, because it's a green file. And now these are slots are empty, no network element here. Okay. And mean here, like we can also see these files here. See? So now, and we know in our project library, I copied these files, which I took from the Nordic 32 files, which was saved in Nordic 32 library test system. So I go to composite frame. I go to frame. Here there's two options, new project frame or select type. I am not creating new project type. That it's not the objective. I want to use what is already defined. So here comes DSL model type. I told you this is a DSL model type where we have written this DSL, AVR, GOV. It's also I mean it's the both are called the block definition, but these are the DSL model type. But we are in composite frame. I click composite frame, and here you see that DigiSilent automatically brought me in the DigiSilent library. And these are the red files created by DigiSilent. So these are the library objects. But I don't want to use that. I want to use what I copied from Nordic test system. I go into my folder, library, dynamic models. I select frame H. I say, okay. The moment I say, okay, you see thus these slots come automatically. Generator, governor, AVR, hydrogen turbine. I say okay. I open again and I want to, I mean, you can name whatever, but just to be make familiar, I say frame H. Just so you can see here, I have a frame H, which I created a object and connected this to this red file, which is frame H. And now you see this are the frame edge red file, and I created the object of this and then connect to this. It's a green file. So I say frame edge. Like both, I just have the same name, but it's the object, the green one. I can also see the diagram of it. For that, I have to minimize it. See, but right now I just have the frame. There is no models in it. It's empty right now. If I can open, you see, these are empty. There is no type. So let's go to again here, and everything is in a data. You have to go through it a bit. So go to network model, network data, great. So now I have a frame, but when I open the frame, you have the slots. You can also open like here, and when I click on frame edge, it's empty. So right now the frame is empty. Now we have to define that dynamic models, or I can say DSL models. So what I say, every time you want to create object, if you are if you want to use from another library object, I created this. I say the DSL. See, when I say write DSL, there's two file came. The one is the DSL green file, and the another one is QDSL, which is quasi dynamic model. We are not going into quasi, we can cover in another video, but right now DSL model. The moment I click this, see, now the DigSILENT already take me to my project under my dynamic model. And right now I want to create my AVR. So when I click AVR, I say okay, and I also name them same like AVR. I say okay. So you see, in the frame edge, I created a DSL model of the same name AVR, and which I connect to this red file. I mean, here we can also check like dynamic models. You see, this this AVR red file and this AVR green file. So this green is the object of this red, and I just connect this. So I can also see from here diagram. You have to minimize this. See, this is the same model they used in Nordic test system, and now I can use in my. So what we have done AVR, we have just used two more, governor and hydrogen turbine, like hydro turbine. Go to the data manager, same process. Now I have one governor and one hydro turbine. Okay, we can also, yeah, like they open. Okay, now I created another DSL model, and now I want GOV. So these are the dynamic models they use in Nordic test system. I'm using the same. I say, okay, this is governor. I say GOV just to be, so we know that which files we are using. Say, okay, and now hydro turbine. So we can also see the diagram of it. Just you see the governor. Sorry, key. Yeah, so we have a governor. And now we are creating another file, ESL, which is hydroturbine. And see, I just use the same name, hydro turbine. I say, okay, just open library so I can show you. So we use AVR, governor, and hydro turbine. So it's the same instances of these objects. So now we have dynamic model to use it. Okay, and this is under frame H, and frame H is also taken from here, which is the composite frame. And in that composite frame, we have three different dynamic models, AVR, governor, DSL. So I I go on grid, and now we have this frame H. I click, and now we have this option. And now I have to connect all this. So, I mean, you can see here in frame H, three dynamic models, and there is a frame which tells how these are connected, but how the network know that we should use in this generator. So we have only one generator. So when I clicked here, it automatically bring me to the grid, and these are the my synchronous machine. And there could be so many machines here if you are working on a bigger project like 100 or maybe less, and like in Nordic we have 20. That's how we created frames. And always remember one thing I will tell you later. First, we have to select this machine. I say okay. I say okay, okay. And now when I open my this, you see this plant model. When I click, you see in generator slot, the synchronous machine network. I put it so now the network knows that this dynamic model or plant model have to use this. Okay, now I go again to here. I mean, I'm going again back end to make things simple, but when you work, you just know. So I say frame match, and now I click on here governor, and now go frame. Under frame match, we created governor. So I select the governor one. I say okay. Now this file came, AVR. Select again, go to frame match. Under frame match, we created AVR. Select AVR. Same in hydro turbine. Select under frame H, hydro turbine. Okay, perfect. And I say okay. And now I go again, and now you can see here plant model. It's always good to do slot update when you complete it. It's a okay. And now when I open this, I can see AVR, but these, you see, we took the this model from the Nordic test system project library, and these are the parameters. So I think to understand how the dynamic model works, my colleague Pauline already created a video about how we created the dynamic models, how we define the input outputs, and how we define the parameters. So these are the parameters we can change it. So and right now its default value is 00. We can also check here, like if you go to description, not description here, type. And then you see how these are the output signals, VE, and input signals, and their state variables and parameters and internal variables. So this is based upon this diagram. It seems complicated, but once you go step by step, it's not complicated. It's very, very simple. So, and like there are so many options here. Let's say these are switch, and these are like you can, this is a lag lead compensator. You can see, and like if you are into dynamic model and you control system, you can easily see. And if you work on MATLAB, it's the same thing, like summation point and different blocks, different constant, integrator, and all. So we are not here to discuss, but you can check my colleague uh, video AVR. So he explained how this work and how we create it from the scratch. We can also make another video how we do from the scratch. It's fine. So, okay, now it's done. Okay. And okay, okay. Now we have dynamic models, which is in the, but we don't know the parameters because mean according to the input output relationship, we define the parameters which we put in the dynamic models. And right now we are not discussing this. We are using the parameters from the Nordic test system, right? So I say, okay, I say, okay, I say, okay. So right now I don't know the parameters, but I want to know it. So I go to the file. I again open the Nordic test system. I don't want to purge my files which I use. So these are my Nordic. Yeah. So I use, so I can just copy from here. I say the governor, I can write it. The governor sigma is 0.04. Okay. AVR, these are the constant. I can just took a picture of it and then I can use the same values. These are the standard values they used in the Nordic test system, and in hydro turbine, they have one. This is water constant. I mean, if you go through how this work, it's a different thing, but we are not here to discuss that. We again open my folder, like my project folder, which I was working on. This is here. So now I'm using the parameters which I copy from the Nordic test system. It was 0.04. Okay. And the AVR, there are different parameters, limits. So can I write it? So this is like if DLIM, it's a field current limiter. Like we are not going into details, but I would like just to emphasize it. And TA, and don't confuse about what is TA, TV. These are just the time constants of different blocks. When you are go into dynamic models, how the control system works according to input output relationships, you can, you will be familiar about it. Right now we just copy it, and you can also change it and see how your input, how your output change. If you change the parameter, it's a good exercises for students who just came into this Power Factory to know how we can use the benchmark model and do different studies, like how things are changing according to changing the different parameters to look the sensitivity of different parameters. Okay, so okay, hydro turbine, and it was water time constant 1. Okay, And if you are curious to know, you can just open it, and here you can like diagram, and then you can also, like, this is the advantage when you import the models from DigiSilent library or any other project file. You can actually change it, you can improvise it. Let's say in your master thesis or in your PhD thesis, you want to create a control loop to integrate something, some extra control. You want to stabilize some gain or something. So from here you can use different signals, you can use different macros. I mean, yes, for that we have another videos about how we can do from the scratch. So you know how you can use different signals. I use as summation points. I just want to show you, and how you can use a different blocks. Let's say I want to use this uh, derivative block. I can just put it and connect the here signal, connect the input output. Oh, sorry, this input output. Yeah, I mean, this cannot be because it should be come from somewhere. So that's how you can actually improvise it according to your objective. So perfect, it's done. Now my plant models is completed. I created this frame, have four slots: generator, governor, AVR, hydroturbine. I use the dynamic models from the my project library. Okay, okay, and I can just check whether. And you know, like whenever you are working with a dynamic simulation, you have to, like here you have simulation because this is RMS or EMT. Like if you are working with root mean square, then you have to do RMS, or if you're working on the instantaneous, you have to work with the EMT. So I just check all the initial condition errors. There's some error. Let me check. What is this? Okay, let's say array parameter arity wrong size. Okay. Mm-hmm. So here it's a click. See, they say like array parameter arity wrong size. Because like if I go to AVR, you see this block has a arity. So this is like when I used the first time, and I had the same thing, and I was so confused that how I solve this problem. And then let's say we go again to the Nordic test system, okay, to understand what's going on, why this array type is wrong size. So when I again go to AVR, and these are the parameters, and you know that, let's see here. I think I open it, yeah, AVR here. So this is like it's to control the integrator wind up. I mean, you can also check like how we can minimize or control the integrator, because when we are integrate something, the we actually sum the error. But if you are doing for a long time, the error add up, and your control uh, your control loop or your control system is not giving you actual output. So that's why in Nordic 32 they use this array windup, and then they actually use integrator. Like this is to control the integrator. And for that, when I go to Nordic again, and then when I open this AVR, and then when I use this advanced, so you see, so this is the integrator wind up, how we can control the integrator input. So the output will be limited. So this is something like including a non-linearity in the input, or we can say, uh, yes, so you can see uh, that the Tx and Ty, so like X and Y relationship, and these are the some crazy values. And why these values are, I already checked. It's to minimize the as smallest error, or to limit the integrator output for a smallest and for a biggest values. So we just copy the same thing. So our model will be working. I mean, if you want to know more about it, you can just ask any chat GPT or DeepSeek or Gemini that what is the meaning of this and how this is impacting this model. Okay. So I copy it. I say, okay, okay. So this I have to copy in my model. I go to my AVR and I advanced one, and events. I have to create size 6, and then these value came, and then I have to write the same values which I copied, -9, -1. Like it's like for no, I think it's -99. For -99, it's 1, and for -0 point, use it seems like a crazy value, but this is how in control system we do things. I even didn't know, but then I checked. It's like giving a relationship to the AVR, so it will not overshoot. Like if even for the smallest value for 00, 99, is it's like giving a input output relationship to the to this block. Okay, okay, okay. Now let's delete this window, clear this, and then when I do execute, perfect. It's run. All the initial conditions are perfectly verified. And when I do this, let's say 50, execute, perfect. It works. So here comes the end of the video. I just want to, I mean, I'm not, you can also do different studies, like you can create events and to see if one variable change, how other variable change. We have a separate video for this, that how we can do the very sophisticated dynamic model studies. Like here is like your edit variables, and here you can create different events like short circuit, like load, and then to see how dynamic models behave in that way. So I can make another video that how we can define the events and see if we want to see that how the dynamic models behaves. But this is the objective, how we can copy the different dynamic models in our file from the Nordic test system. Once again, I would like to uh, to rep- to summarize everything that here this bold represent my current project, which is the Nordic 32 dynamic model. I just name it so I can use the dynamic model saved in Nordic test system. When I go to library, dynamic models, these are the files I copied from the Nordic test system library. And then when I go to the network model, network data and grid, these are the network elements. I created a frame H and I connected this frame H. I connected this frame H to this frame, which is my library object. And in frame H, I created three objects of governor hydrogen in AVR, which is also in these in the library of my current project. And here how we can use it, we cannot use directly. We have to follow this method. And thank you so much. And I think you have at least a bit understanding how we can use different dynamic models from a benchmark test system to our defined small system if you want to use or to make study very simple, because if you want to study Nordic 32, there are so many buses, generator, transformer, but here we have just a small test system. I think that's interesting. And always remember how many times you want to access those library object. That many times you have to create these green files, or I can say instances, network object or instances of this library objects. If I want to use, if let's say if I have five generators, so I have to create this frame edge object five times and then connect these green files to the red files five times. Imagine I use another generator with thermal, so I have to connect frame T to that green file. So I think I make it very simple. Thank you so much. And I hope this will help you to understand the power system more and can use for your master thesis, your bachelor thesis, or your PhD. Thank you so much. And I wish you all the best. Thank you.